You know that feeling when you hand over a massive pull request to a general purpose AI agent, crossing your fingers it'll catch your bugs, only for it to completely hallucinate the line numbers? Or worse, it just randomly skips half the files? We've all been there, right? It's an incredibly common frustration, the kind that makes you want to literally toss your keyboard out the window. We desperately want AI to speed up our code reviews, but when it faceplants on these basic edge cases, it honestly just creates more work for us. Welcome to this explainer. Today we're focusing on an open source tool simply called Open Code Review. It was originally developed at Alibaba Group, and as you'll see, it brilliantly illustrates how we can move way beyond just throwing natural language at a code base. It fundamentally changes how the AI interacts with our code. Here's our roadmap for today. We'll start with the AI code review problem, meet Open Code Review, dive into its hybrid architecture, check out how to customize your review rules, and wrap up with workflow integration options. Let's jump in. Part 1. The AI code review problem. What actually goes wrong? If you've tried using general agents like Claude, Code with standard skills for your reviews, you've definitely hit these roadblocks. First step is incomplete coverage. On larger change sets, the AI just gets overwhelmed. It cuts corners and silently skips files. Second is position drift. This one drives me absolutely crazy. The AI actually finds a real issue, but the line numbers it gives you drift off target, so they don't match reality at all. And third is unstable quality. Because these tools rely purely on natural language skills, they're super hard to debug. Just a tiny, subtle tweak in your prompt can cause the review quality to fluctuate wildly. So why exactly does this happen? Well, it all boils down to the architecture. The root cause is that a purely language-driven setup simply lacks hard constraints. Look, an LLM is fantastic at dynamic reasoning and spotting logic flaws, right? But it is terrible at strict deterministic counting and routing. When you ask a language model to organically keep track of exact file paths and calculate precise line numbers across a massive Git diff, you're fundamentally using the wrong tool for the job. Moving on to Section 2, meet Open Code Review, the hybrid CLI tool. Before we get into the mechanics of how it works, just look at this number. Millions of defects found internally. This isn't some weekend hackathon project. Before it was incubated into an open source project for the community, this tool was Alibaba Group's official internal AI code review assistant. It was battle tested by tens of thousands of developers over 2 years at a massive scale. That kind of real-world validation is exactly why we need to pay attention to this approach. So, at a surface level, what is it? Basically, it's a command line interface tool. It reads your Git diffs, sends the changed files to an LLM of your choice via an agent, and then spits out structured review comments with absolute line-level precision. And it goes beyond a shallow surface diff. The agent has actual tool use capabilities, meaning it can read full file contents, search your codebase, and pull in other changed files for context, so it can give you deep, genuinely meaningful reviews. All right, Section 3, the hybrid architecture solution, where engineering meets the agent. Here is the core philosophy behind it all, a hybrid architecture. Think of it like combining strict rails with a dynamic brain. It takes the strict, hard constraints of deterministic engineering pipelines, those are your rails, and merges them with the dynamic decision-making of an LLM agent, which is your brain. Instead of asking the LLM to do everything, each side handles exactly what it does best. Notice the division of labor here. On the left side, we've got deterministic engineering. This handles the stuff that absolutely cannot go wrong. Precise file selection makes sure no important change is missed. Smart file bundling groups related items together, and fine-grained template rules filter out the noise. Then, on the right side, the LLM agent steps in for the actual analysis. It uses scenario-tuned prompts optimized specifically for code review, purpose-built toolsets distilled directly from massive production data, and dynamic context retrieval. Let's zoom in on that deterministic side for a second to see how it fixes the exact pain points we talked about earlier. Smart file bundling is a super clever divide-and-conquer strategy. It groups related files together, say bundling an English message properties file with the Chinese translation equivalent, so the AI keeps its context and stays stable, even on giant change sets. Next, template engine roles guide the review, which is way more predictable than relying purely on natural language prompts. And here's the real game changer. Independent external modules handle the comment positioning. The AI literally doesn't have to guess line numbers anymore. The deterministic code calculates them. Position drift, totally eliminated. Section 4. Customizing review rules. How to tailor this to your codebase.
So, Open Code Review uses a really neat 4-layer priority chain to resolve its rules, and it operates strictly on a first match wins basis. At the very top, Priority 1 is an explicit CLI override. You just use a flag. Priority 2 is your project config living right in your repo so your whole team is on the same page. Priority 3 is a global config for your own personal developer setup. And if all else fails, Priority 4 drops back to the embedded system defaults, which already cover most common languages and file types.
You are completely in the driver's seat when it comes to the scope of the review. You get absolute granular control using simple include and exclude path filtering. You can use exclude fields to instantly filter out binary files or paths you just don't care about, and excludes will always win. But the include fields are just as important because they let you bypass built-in default excludes. Like, by default, the system ignores test files to save tokens. But if you want the AI to review your tests, just add an include rule. You are always steering the ship. Finally, Section 5, Workflow Integration Options. Let's plug this into your daily routines. The developers provided a really great variety of ways to plug this tool in. You can run it manually from the CLI by installing it globally via NPM. If you're already using AI coding agents, you can install it as a command plugin for Claude Code to get a seamless slash command or integrate it as a local codex skill. But honestly, the ultimate setup is the CI/CD integration. You drop this into GitHub Actions or GitLab CI, output the results in JSON format, and let it handle fork pull requests using commit SHAs. It essentially becomes your automated gatekeeper, running its deterministic review on every single push while you go grab your morning coffee. And honestly, the best part? No vendor lock-in. You bring your own model endpoint. The tool plays nicely with OpenAI, Anthropic, DashScope, DeepSeek, you name it. You just punch in your API key and URL or let it parse your existing Claude code environment variables, and the tool seamlessly routes the prompts to whatever backend you prefer. There's even an interactive terminal setup to make the whole configuration painless. Which brings us to our final takeaway. The source code is out there. The rules are fully configurable, and this hybrid architecture fundamentally solves the frustrating reliability issues that have plagued purely language-driven AI agents up until now. So, the question I want to leave you with is this. Are you ready to let a hybrid agent find the bugs in your next pull request? Thanks so much for joining me for this explainer. Keep learning, keep building, and definitely go check out this open source tool for yourself.